All right, here we go. So let's work on the bus route first. All right, so we have 4 cities, so we'll do a 4x4 matrix. If it helps for you to write out 1, 2, 3, 4 here, 1, 2, 3, 4 here, by all means do that. There is nothing wrong with that, just so you can kind of see what city you're going from.
Origin is on the left, right?
The origin, what do you mean? You can actually start anywhere. So if you want it to be random and go, I want to do city 3 first and I want to start at city 2, you could start the matrix there if you wanted to. Typically, though, in math, we go left to right, bottom to top. But really and truly, when making this matrix, it doesn't really matter. All right, so I'll start from city 1 and go to all the cities. Bus, again, are the solids. So how many routes can I get from 1 to 1? 1. 1 to 2. 1 to 3. 1 to 4. Very good. 2 to 1. Very good. Again, notice, pay attention to those arrows. This red one does not get back to 1. 2 to 2. 2 to 3. Ooh, 2 to 3 would be 2 in this case. There's 2 arrows going in that direction, even though from 3 to 2, it will be 1. But from 2 to 3, it is 2. 2 to 4. 2. 3 to 1. 3 to 2. 1 this time. And then 3 to 3. 3 to 4. 4 to 1. 4 to 2. 4 to 3. 4 to 4. Anyone have any questions on yesterday on that? All right, let's check our subway. Again, still got 4 cities, so if it helps to do your labeling, by all means. Again, this time we're going to pay attention to the dotted lines. So from 1 to 1, 0 this time. 1 to 2, 1 to 3, 1 to 4, 1. So we see this long dotted line going way over there. Perfect. 2 to 1, 2 to 2, 2 to 3. Oh, yep, because there's not a second arrow there. 2 to 4, 3 to 1, 3 to 2, 2 this time, good. 3 to 3, 3 to 4. Ooh, tricky there, yep. 4 to 1, 4 to 2, 4 to 3, 4 to 4. Any questions there? So we're good with that. All right, let's bounce back to the lesson 1 and let's finish up that friends one. Answer some questions, come back to this. We'll use this matrix to do arithmetics with and kind of go from there. So here we go. It looks super complicated. Don't let it scare you. But basically what this network is basically doing is just telling you out of 11 people who's friends with who. So you can see that 1 is friends with 3, 4, 5, and also 7, 8, 9, and 11. But then you can see that friend or person 2 only has 1 friend with 7, right? So that's kind of what this network is showing. And we're going to make a matrix out of this. So these are just connections. So they go both directions. So if there's a line that connects them, it's just a value of 1. So when we come over here and we create this matrix here, so I can have the device, you will see once again, this is friend 1. And these are friends 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can see friend 1 is not friends with himself, but he is friends with 3, 4, 5, 7, 8, 9, 11. So we'll put a 1 with them if they're friends, zeros if there's no connection. All right. I'll do friend 2 with you, and then I'll give you a chance to fill this out as well. So when looking at, again, friend 2, we see that there's only one connection at 7. So that would mean everything would get what? Except for, very good. So this would be 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. Go ahead and fill out the rest of this chart, and then we'll check it here in a second, and then answer some questions that go with it. And then that will wrap up lesson 1, and lesson 2 will be more of a review from last semester. Big thing on this friendship thing, don't forget to also look at the lines below it so you can see multiple connections there. While you're working on this, congratulations, you're working on computer science. Coding. Bunch of ones and zeros, on and off switches. See, I didn't think pre-cal could be so easy. We haven't seen one eye yet. I don't think so. Are we ready to check it? All right, so I'm going to try to use my little diagram I have. So we're looking at friend 3. Friend 3 is going to be friends with friend 1. So 5, 6, and 7. Right, and the rest are zeros. I'll go with that. All right, I'll move on to friend 4. It looks like he only has friends with 1. Hmm? 4? Yeah. Yeah, friends has friends. 4 is friends with 1. Oh, that's fine. I probably didn't say it correctly. 4 has friends with 1. Not, well, he has 1 friend, but it's also friend 1. Yeah. Well, I think I said it as 4 is friends with 1, as in like 1 person, but it's actually the number 1 that he's 1 friend with, which is number 1. All right. Anyways, all right. 5 looks like he's friends with 1, 3, 7, and then yeah, and then not 9. No, he's friends with 10 and 11. Oh, he does. I see the circle back. That's a weird way to do it. You're right. So 9, 10, 11. See that little curve back? It goes through in between 10 and 11 and then circles back up to 9. Yeah, if they had little things. You see the little curve? Yeah. I didn't see it either until they said it. So follow this curve and it goes all the way back around that. I would have thought that was 11 there in between. All right, so then the rest would be zeros. That's a 1, by the way. Those are zeros. All right, number 6. Looks like he's friends with 3. And that's it. And a lot of these people don't have many friends. And some have too many friends. 7 looks like friends with 5. Also 1, 2, and 3. And then also 9 and 10. Did I get all those for 7? No tricky little curves in between all that. Friend 8. Looked like he only has 1 friend, and it is friend 1. Friend 9. Looks like he's friends with 7. 1, 11, and 5. So he's friends with 1, 11, and 9. Did I get them all? A little tricky 9 there, though. 10 would be 7. 5. And it looks like that's it. 9 is friends with 1, 7, and 5. Did I not put it on 5? Oh, okay. I see. I put it on 9 and it's supposed to be on 5. Yeah, I got 11 there. So here we go. There's 5. There we go. Does that make more sense? All right. So then again, 10 looks like he's only friends with 7 and 5. And then 11 is friends with 5. 9 and 1. As I was doing this, I was curious if the pattern was going to be the same. And it is. So once you did this right here, I could have done this. Once I did this, I could have gone like this. Once I did this one, I could have gone this direction. So once you finished a row, you knew the next column. I thought that halfway through, and I was like, I bet that's how that works. I don't know. Anyone else catch that? Yeah. Yeah. So like for instance, you see how this row is 0, 0, 1, 1, 1. Well, let's do an easier one. Let's look at this recall. This row here is nothing but zeros except for at 7. So that means column two will be nothing but zeros except for at 7. So the row one will repeat column one, row two will repeat column two, row three will repeat column three, and so on and so on. So there was a, I forget they called this something like a asymmetric matrix or something like that. I don't think that's important, but something that was kind of interesting there. All right, but let's answer some of the following questions that go with it. So part A says number one is not friends with number 10. How many ways could number one get a message to number 10 by only going through one friend? Think about it, work through it, and then we'll come together. Easiest way to think about this is think about who's friends with 10. Now, those friends who's also friends with 1. Got it? Are you ready? How many ways? There's 2. So if you think about your friends with 10, I have 5 as friends with 10, 7 is friends with 10, and that's it. There's only 2 ways. So then we just got to go, all right, on friend 1, is he also friends with 5, which he is, and is he also friends with 7, which he is. So therefore, 10 and 1 can be connected through 5 and 7. So there are 2 ways. And friend 1 can either go to 5, that will get to 10, or you can go to 7, which will get to 10. Any questions on how to analyze that? So go where you're ending, figure out who connects to that, and then see who connects to who your beginning is. So part B then says, who has the most friends in the network? Again, look at it first, think about it. Most of you are already staring at me. So who is it? Number 1, right? How many friends does he have? How would you figure that out? Just count the row or even the column that goes with it. Here I see that he has 7, and then you can kind of go from there. Or you can just realize that he just has way more ones than everyone else. So again, that would be number 1. He has 7 friends. Any questions so far? All righty. I'm going to have to erase this, so make sure you have that matrix so you answer the last 2 questions, and that will wrap up lesson 1. So in C, it says, is everyone in this network connected at least as a friend of a friend? Basically, what that means is a friend of a friend can everyone get to everybody. So, like for instance, 1 wasn't friends with 10, but he had 2 mutual friends he was able to get a message to. So, is every friend able to get to every friend? Who? Who? 2 can't get to who? He can get to 6. 2 can get to 11. 2 can get to 8. No, multiple ways. So, it's a connection. Oh, I see. Okay. So, it means just one friend. So, there has to be one friend in between. So, not multiple friends. You said 2 can't get to 8 because of 1, and that's just one friend. So, is there anybody that doesn't have At least a friend of a friend. So if you go through two friends, that's too many friends. Only one friend in between. 6 to 11. So if 6 goes to 3, 3 can't go to 11. Yep. So that would be a 1. 2, let's see. So 2 goes to 7, and then 7 can't get to 6. All right. I like that. I see now. All right, perfect. So this will definitely be no, and you can put any one of those examples that you just came up with. The one the book came up with is 2 couldn't get to 4, but the same reasons as y'all's as well. All right, so any questions there? So any of those ones that cannot get to a friend from a friend. On part D, what is the entry for A23? How do we read that? A23, what's that mean? Row 2, column 3. So you want to say it as row 2, column 3. So when I go to row 2, column 3, what's the value there? 0. What's the meaning? There it is. 2 is not friends. Oh, there's an R somewhere in there. Friends? No. Is that right? That looks weird. So 2 is not friends with 3. Questions? We're good with that? All right, let's bounce back to lesson 2. You'll find lesson 2 to be more of a review of arithmetic that we did towards the end of the semester of adding, subtracting, and multiplying matrices. We're going to use those 2 matrices that you came up with for the bus and subways in that opening exercise. Let's bounce over there, and then this will wrap up today's events. So in part question 1 here, it says, suppose the number of bus routes between each city were doubled. What do you think would happen to the matrix? Perfect. So like if every bus route doubled, the entire matrix would double. Go ahead and write that matrix out. The doubled matrix of the bus routes from the opening exercise that you did, double all those numbers. Real quick, what 0 doubled? Are we ready? So you should have gotten what? What's the first row? Column is up and down. Row is across. So these are your rows. These are your columns. So what was the first row? 2, 6, 2, 0. Second row? Third row? 0, 2. All right. And then the last row? Perfect. Any questions on how to double a matrix? All right. The correct notation for this doubled matrix is written as 2B. Now they wrote it with the B because what did we want the bus matrix to be called? B. So mathematicians would call this matrix 2B, and you would and why do you think it's called that? Everything was multiplied by 2. So if we double something, it'd be multiplied by 2. If we tripled something, it would be considered what? 3B, right? If we wanted quadrupled, it would be 4B, and so on and so on. Right? That 2 is considered a scalar multiple, just simply meaning it's a value in which you multiplied every element inside that matrix by that scalar. So part 2 then says, what would be the meaning of 10B in this situation? Every route would have been multiplied by 10, right? So every bus route would be multiplied by 10. Yes, part 2 wants you to write it out, but part 3 wants you to actually develop the matrix. So what would the first row of the 10B matrix be? Yes, perfect. Yes, sorry. 10, 30, 10, 0. Notice we are multiplying the original bus by 10. So when we do this, this looks more like this. So again, we're multiplying the original matrix by 10, not the doubled matrix. So then you should have also gotten 20, 0, 20, 20, 20, 10, 0, 10, 0, 20, 10, 0. I try to put space in there because even just looking at this matrix, it looks like 10s and 22s. And so make sure you understand what you're writing as well. Any questions so far on how to multiply by a scalar multiple? Pretty straightforward. All right, let's keep trucking along. Ain't much harder than that. All right, so let's ignore whether or not a line connecting cities represents a bus or a subway route. I want you to create one matrix that represents all the routes between the cities and the transportation network. Yep, so consider the dotted and solid as options to get from city 1 to city 2. So one gigantic matrix. Go ahead and take this time to do that. Try it. See if you add them up versus doing it by looking at the network and see if there's a connection. It's awesome to make assumptions, but we want to back it up with facts. And if the fact works, then the assumption can be a theory. Very good. So what did we end up getting when we looked at all the routes combined as our matrix? Let's start with row 1. 1, 4, 2, 1. Row 2. Row 3. Row 4. So did that actually end up being the bus matrix plus the subway matrix? Very good. So we're trying to find the total. This is in fact the same thing as B plus not a 3, S, which in this case would have been 1310 2022 2101 and 0210. Add it to the subway bus, which was 0111 1012 121. Nope, 01, and then 1120. All right, so something like that in a cleaner form. We just added each element to total up the each element in the total amount of transportation networks. So why would it be appropriate to call this matrix B plus S? Because it is, right? You're adding both routes together or anything along those lines. Any questions so far? All righty. Again, it doesn't get much harder. On part 5, what would then the meaning of 4b plus 2s be? Again, we're not figuring it out, but what would the meaning of this be? Perfect. There you go. So you would basically say that you're quadrupling your bus routes and doubling your subway routes to give you a new total amount of transportations. I love the interpretation there. So there you go. So anything along those things. So quadruple. I'm going to make, maybe it looks like that. Quadruple the bus routes and double the subway routes. Then add the routes together. All right. Once you have that, now go ahead and figure out what 4b plus 2s is. You might need to do a little pre-work, maybe figure out what 4b is and 2s is, and then add them together after that. I will say one of the biggest questions I always get is the order of operation matter? Well, if you think of PEMDAS, what do we typically do first? Multiply or add? So you do have to multiply those scalars first before you add your matrices up. Right now, it's not a big deal because they're obviously different values, but if they were both the same, that's usually where students go awry. And so again, the first thing you want to do is do the scalar multiplying first. So I'm going to multiply everything in the bus routes by 4, and you should have gotten 4, 12, 4, 0, 8, 0. Yeah, good. 8, 8, 8, 4, 0, 4, 0, 8, 4, 0. Everyone good with that? All right. After that point, you should have then for the subways gotten 0, 2, 2, 2, 2, 0, 2, 4, 2, 4, 0, 2, 2, 2, 4, 0. And then to add these both up, I'm just going to add each element up. So that should have been 4, 14, 6, 2, 10, 0, 10, 12, 10, 8, 0, 6, 2, 10, 8, and then 0. We all good with that? All right, that's about as complicated as it gets. So what I want to do now is just kind of give you a little graphic organizer to kind of organize all of that. And then that's all I got for today. So out of these two sections, how are we feeling about the first test? There's only one more topic I got to teach. All right, good deal. I'm hoping having more multiple tests will help you out a lot better than having just one or two gigantic tests. All right, so here is basically everything we have seen up to this point, even from last semester, but mainly just regarding what we've seen here recently or today. You have scalar multiplication, which is going to be some k value times a random matrix. So again, the description here is we're just going to simply multiply each element in matrix A by the scalar k, whatever that k value might be. Right? We've seen 10 times b, 2 times b, 4 times b, whatever that k is. So for example, you could have something like this: 2 times 1, 1, 2, 2, 2, 4, 3, 0, 0. Go ahead and tell me what that matrix would be. Don't say it out loud, but write it down in your notes to give yourself an example. Again, that is a 1, 1, 2, 2, 2, 4, 3, 0, 0. We all got an answer? All right. Again, I'm just going to take that scalar, multiply to every element in that matrix. So in this case, it would be 2, 2, 4, 4, 4, 8, 6, 0, 0. You good with all that? All right. The next thing we talked about was how to add matrices up. So adding A plus B, basically you're going to add each corresponding element, I guess, from matrix A and B. For example, you would add element A11 plus element B11 to give your new total. Mm-hmm. So here's the example I'll let you try. 1, 1, 2, 2, 2, 4, 300, the one just like the above, plus the one you just added. This example, look, 1 1. Yeah, so that would be like your row one, row one, column one for its corresponding, and that would add your total. So this would be 2 2 4 4 4 8 6 0 0. Go ahead and take this time to add those up. Make sure you can add matrices correctly. And then we'll talk about subtraction. And then that'll wrap it up. I think I got about, what, 4 minutes to spare? And we're doing pretty good. I got an answer. 3 3 6 6 6 12 9 0 0. Perfect. All right, this last one was subtraction. I know we didn't do an actual subtraction problem, but it'd be the same thing as adding. You would literally just subtract each corresponding elements from matrix A and B. For example, you would take element A11 and subtract it from element B11 to get your new element. So what we're going to do is take this exact same example. Now I want you to subtract them. And see if you can do that correctly. And again, that will wrap up today. They did do a little interpretation here. If subtracting is complicated for you, you could multiply by -1 first and then add the result. I find that to be more complicated, but by all means, there's a second way. It really does. So 1 minus 2 is -1. Keep going. Perfect. So I did take the original one and change all the signs, but that's not how it always works. That's just examples that we get. Any questions? So 67% of this material you got down? Awesome.